Hello, and thank you for joining us for the 5th episode of Burning Questions, a podcast focused on reducing risk in your communities and answering some of your questions along the way. In each episode, we'll focus on one safety topic that we get a lot of questions about. We'll do our best to answer some of those questions, and we'll try and clear up any misconceptions about those topics while we're at it. If you have any questions you'd like for us to answer, leave a voicemail for us at 864-430-0510 or email us at bsfdpodcast@gmail.com, and we'll try and give you an answer in a later episode. Today, my guest is Engineer Hayden Knapp. He's been with us for about 5 years now. He helps us operate our tiller truck, and he's going to teach us some things about lithium-ion batteries today. We're going to cover the technology behind it, the risks associated with it, some best practices, as well as some safety issues, causes of some lithium-ion fires, and then we'll talk about some case studies that we've seen in the past. So first off, how are you doing, Hayden?
I'm good. How are you doing?
I'm doing excellent. So today we're going to talk about lithium-ion technology. First off, we just need to understand how that technology works. So Hayden, can you walk us through how exactly do lithium-ion batteries work?
Yeah, absolutely. A typical lithium-ion battery consists of several cells. Each contain positive electrodes known as a cathode, a negative electrode also known as an anode, and the electrolyte that facilitates the movement of ions between the electrodes. When the battery is charged, lithium ions are transferred from the positive electrode to the negative electrode through the electrolyte. This creates a buildup of electrons on the negative electrode, which creates an electrical potential difference between the two electrodes. When the battery is connected to a circuit, these electrons flow from the negative electrode through the circuit and back to the positive electrode, creating an electrical current.
Okay, and then that shows us how it's charged. What about when the battery is discharged?
Okay, when the battery is discharged, the process is reversed. The lithium ions move back from the negative electrode and they move to the positive electrode, releasing their energy and creating an electrical current actually in the opposite direction.
So what's something that makes lithium-ion batteries unique?
Well, they're unique because of a variety of different materials to transfer the ions. The positive electrode typically contains a lithium metal oxide, while the negative electrode contains graphite or another carbon-based material. The electrolyte is usually a lithium salt dissolved in an organic solvent.
That's really interesting. And correct me if I'm wrong, but one of the advantages of lithium-ion technology is that it has a high energy density. And that just means that it can store a lot more energy in a smaller package.
No, that's exactly right, and it makes it ideal for portable electronics and electric vehicles. Lithium-ion batteries also have a super long lifespan that can be recharged hundreds of times before they start to degrade like a regular battery.
So Hayden, we've talked about kind of the science behind lithium-ion batteries. What are some of the risks that are associated with lithium-ion batteries?
Yeah, absolutely. That's something we always got to talk about. First and foremost, lithium-ion batteries can be prone to overheating and fire if they're damaged or used improperly. This is because the electrolyte in the lithium-ion batteries is actually flammable, and if it overheats, it can ignite and start a fire. This is a serious risk, especially in applications where the batteries are exposed to high temperatures or even physical damage. Also, another risk associated with lithium-ion batteries is they can actually do a thing called thermal runaway. This occurs when the battery gets too hot and the heat starts to build up inside the cell. It actually causes a chain reaction that generates more heat, and it just gets hotter and hotter, and this can lead to a rapid increase in temperature and ultimately results in an explosion.
So we've talked about physical damage. What kinds of damage are we talking about? Are we just talking about dropping or penetrating the battery, or are we also talking about chemical and thermal damage?
No, that's a super good question. The mechanical damage, I guess you could say, if like a battery is punctured or crushed, it can cause a short circuit that can lead to a fire or explosion. That's why it's important to handle lithium-ion batteries carefully and just try to avoid exposing them to damage. Just take as good as care as possible.
Okay, and is there any risk of overcharging these batteries?
Absolutely. If you overcharge them and they're not managed properly, it will also cause a fire or an explosion over time.
And just to clarify, if you use the lithium-ion battery just like the manufacturer intended, and you use the manufacturer-provided charging cable, this risk is exponentially lower than if you use aftermarket parts, aftermarket chargers, or aftermarket batteries in your electronics. And this leads us to the next section, which is the best practices for lithium-ion battery usage. Is there something else you could tell us about what some of these best practices might be when it comes to lithium-ion batteries in our homes?
Yeah, absolutely. Some of those best practices also go into what we just talked about, making sure they're always safe, don't expose them to any mechanical damage, but also make sure you're only using certified batteries. These are batteries that have been through some sort of safety standard testing. Avoid extreme temperatures. Lithium-ion batteries should be kept anywhere between 68 to 77 degrees to avoid overheating and thermal runaway.
Okay, and when it comes to that range, I think most of the times what we're talking about here is if you leave your cell phone sitting on the dashboard of your car, if you have some kind of electronic device, you leave it in a closed car, the temperature goes up to about 120 degrees in 10-15 minutes?
10-15 minutes, and you'll actually see, and your phones are built in now, that they'll actually start shutting off once it gets that temperature, but that doesn't mean the battery itself is safe.
That's a good point.
And using the correct charger. Always use the charger that comes with your battery or a charger that's compatible with your battery specifications. Using the wrong charger can cause the battery to overcharge, and that's ultimately what leads to fire and explosions.
Okay, and are there any issues that people have run into in the past with storing their lithium-ion batteries or handling their lithium-ion batteries?
Yeah, it's absolutely. It's kind of like the car thing. But also, what you can add to that is store batteries in a cool, dry place and away from direct sunlight, so keep it in the shade. Avoid storing them in hot environments, like we said, inside the car.
Okay, and what if we have a lithium-ion battery that we're concerned about or it's starting to show signs of failure? How do we dispose of that?
Yeah, absolutely. When disposing of the lithium-ion battery, be sure to follow the proper recycling guidelines in your area. Don't just throw them away in the trash or recycle them with other materials.
That's a good point, because if you do have a lithium-ion battery that's showing signs of damage, whether it's physical, chemical, or thermal, the last thing you'd want to do is put it outside in your trash can right next to your vinyl siding house. That can be a serious fire hazard in and of itself. And while we're talking about possible fires, what are some of the causes of lithium-ion battery fires that we've seen?
Overcharging, physical damage, manufacturing defects, exposure to extreme temperatures, and aging. Aging is a super important topic I want to talk about. As lithium-ion batteries age, their capacity and performance can degrade. When a battery reaches the end of its life, it may become more prone to failure, overheating, and other safety risks.
That's a good point, and by understanding some of these common causes that we've been talking about, you can take steps to mitigate those risks and use lithium-ion technology safely. In future episodes, we'll explore some of the causes in more detail and discuss strategies to prevent battery failures, but I wanted to cover those basics on how to stay safe with lithium-ion technology in your home.
With lithium-ion batteries, it's in everything that we have in our house nowadays. I mean, everything's coming out rechargeable. It's something that we don't think about often, but it's something that we should do a little bit more research on.
And as this technology progresses, it leads us into our next topic, which is talking about some of the safety standards regarding lithium-ion technology that have been put in place in the last few years regarding safety, overcharging, and different automatic features that these batteries have inside them that they didn't have previously. Can you talk a little bit more about some of these safety standards that we're talking about?
The UNDOT testing. The United Nations has established a set of tests to evaluate the safety of lithium-ion batteries for transportation. These tests evaluate the battery's ability to withstand various environmental stresses and impact forces during transportation. The IEC standard has established several standards for lithium-ion batteries, including safety requirements for secondary lithium cells and batteries. These standards covers various aspects of the battery's design and testing, including electrical performance, mechanical design, and abuse testing.
And the one that most people are most familiar with would be UL, or Underwriters Laboratory. Can you tell us a little bit more about some of their safety standards?
Underwriters Laboratories is an independent safety certification organization that established standards for lithium-ion batteries used in consumer products. These standards cover various aspects of batteries, including overcharging protection, short-circuit protection, and even temperature control.
And that covers UN, DOT, IEC, and UL standards. Are there any national or regional standards that address lithium-ion safety directly?
Absolutely. Many countries and regions have their own safety standards for lithium-ion batteries, which may be based on international standards or tailored to local requirements. For example, the United States, the National Fire Protection Association has established a standard for lithium-ion batteries used in stationary energy storage systems.
And when we say energy storage systems, a lot of times what that's referring to is like the Tesla wall pack or the Tesla wall battery, correct?
Yeah, absolutely. Adhering to these safety standards, manufacturers and users can ensure that lithium-ion batteries are designed, tested, and used in a safe and responsible manner. These tests, standards, and other requirements are all in place to ensure that these batteries are safe as possible. This is why we emphasized the importance of only purchasing and using batteries that are constructed in accordance to these standards. Untested construction methods for lithium-ion technology can lead to manufacturing faults and overheating issues, causing battery failure, thermal runaway, and resulting in the high-intensity fires we talked about earlier.
And this gets us into the next section, With those thermal runaway events and these high-intensity fires, are there any issues that the fire service is specifically facing with this newer lithium-ion technology?
Oh, absolutely. We're facing a lot of things right now. One of them is toxic fumes. Lithium-ion batteries can produce toxic fumes that can be hazardous to firefighters and other first responders. These fumes contain chemicals such as carbon monoxide, hydrogen fluoride, and phosphorus pentoxide, which can cause respiratory irritation and other health problems.
These fumes impact the modern fire service by requiring us to wear our self-contained breathing apparatus, or SCBA, on scenes that we normally wouldn't have to wear that PPE, or personal protective equipment. It also can lead to an additional decontamination that we have to do after what would normally be a routine vehicle fire. It just takes a lot more time to get back in service after these fires because there's so much additional work that needs to be done.
We talked about thermal runaway earlier, and that's where the fire generates its own heat and becomes self-sustaining. This can make it difficult for firefighters to extinguish the fire, as it may continue to burn even after the initial flames are extinguished.
And these fires impact us in several different ways, but one of them is that our standard or our tried and true methods of extinguishment just aren't effective. We can usually put out a vehicle fire with between 300 to 750 gallons of water, but these fires, they can actually burn underwater, and if they do go out, they can reignite several hours later or even days later.
Traditional firefighting methods, like you talked about using water, these fires actually, it makes them worse. They can actually cause explosions, and it can react with the chemicals inside the batteries. Cooling batteries that are going to thermal runaway takes a lot of water delivered over extended periods of time. Not feasible for interstate or major highway incidents since there's limited water supply, and the impact of traffic patterns will be a nightmare.
So what happens a lot is our firefighters arrive on scene for what's dispatched as a working vehicle fire, and sometimes there are very few or very limited labels, decals, names, any kind of indicators on the outside of the vehicle that say that this is an electric vehicle. We run into this all the time, and it means that your standard practices are not going to be effective, and a lot of times you won't know that until you've already tried to put those standard practices into place, and then they are just not functioning like you want them to. So having some way of identifying these vehicles can make all the difference in firefighter safety.
Oh, absolutely. It's important for manufacturers to provide detailed information about the battery's composition, handling instructions, and even safety precautions for us firefighters on scene. By understanding these issues and taking steps to address them, the fire service can better prepare for and respond to lithium-ion battery fires. Manufacturers can also play a role by providing clear and detailed information about their batteries, working with the fire service, and that helps us develop effective response strategies if we do have to respond to a fire like this.
And while we're talking about fires related to lithium-ion technology, I wanted to go ahead and go into some of the case studies. We have 4 different case studies I want to dive into really quickly. Hayden, can you tell us about the Tesla Model S fire in Shanghai?
That was in April 2019. A Tesla Model S caught fire in a parking garage in Shanghai, China. The cause of the fire was not immediately clear. However, the incident raised concerns about the safety of Tesla's lithium-ion batteries. Well, upon further investigation, it was found that the battery pack in the vehicle had been damaged due to an impact from a hard object on the road. This damage resulted in a short circuit, which eventually led to the fire. While Tesla's batteries are designed to withstand impacts, the specific nature of this incident led to the failure of the battery. This incident highlights the importance of proper handling and maintenance of electric vehicles, as well as the need for proper design and testing of battery packs to prevent thermal runaway and other hazards.
And our second case study has to do with Korean Air Cargo Flight 6316. Can you tell us a little bit about that?
July 2011, a Korean air cargo flight carrying lithium-ion batteries crashed near Birmingham, Alabama, killing both the pilots on board. The incident was caused by a fire that started in the cargo hold, which was carrying over 5,000 pounds of lithium-ion batteries. The National Transportation Safety Board investigated the incident and found that the batteries had not been properly declared in the package for air transport. In addition, the NTSB found that the design and testing of the batteries did not adequately address the risk of thermal runaway. This incident highlighted the need for proper handling and transport of lithium-ion batteries, as well as the importance of proper testing of these batteries to prevent hazards during transport. It also led to changes in regulations surrounding the transport of lithium-ion batteries on aircrafts.
And our third case study is talking about the infamous hoverboard fires that we all knew about from about 2015 to 2018. Can you go into a little bit more detail on those?
Yeah, in 2015, that's when they kind of became super popular, and they were a must-have in most households across the United States. However, the excitement around these vehicles quickly turned to concern, as reports of hoverboards catching fire or exploding. The cause of these fires were found to be lithium-ion batteries inside the hoverboards. The Consumer Product Safety Commission investigated these incidents and found that the batteries in some hoverboards did not meet safety standards and were prone to overheating, catching fire, or exploding. The CPSC subsequently issued recalls of several brands of hoverboards, and the incidents led to an increased scrutiny of the safety of lithium-ion batteries.
And our fourth case study has to do with a gas station explosion in San Francisco in 2019. Can you tell us a little bit about that?
Yeah, in 2019, a gas station in San Francisco, California experienced an explosion and fire that was caused by the failure of a lithium-ion battery in an electric vehicle. The battery had been recently replaced and was being charged at the time of the incident. The explosion was so powerful that it blew the roof off the gas station and caused significant damage to nearby buildings. Fortunately, no one was injured in this accident. The accident highlights the importance of proper handling and maintenance of the electric vehicle batteries, just like we've been talking about.
That's a good point. We talked about some of the existing safety issues and how they impact the fire service. What about some of the future lithium-ion technology? How is that going to impact the fire service?
Some of the things that they're going to are solid-state batteries, battery management systems, different advanced materials, and new standards and regulations. Solid-state batteries are emerging technology that uses solid electrolytes instead of liquid electrolytes. They have the potential to improve battery safety because they are less prone to thermal runaway, and they're a lot less flammable. Solid-state batteries also have potential to offer higher energy densities, longer lifetimes, and faster charging times than current lithium-ion batteries. Battery management systems are designed to monitor and control battery performance safety. They can help prevent thermal runaway by monitoring the battery temperature and controlling the charging and discharge rates. Advanced BMS systems can also detect potential safety issues and can also take corrective actions such as isolating a faulty cell.
So what about the advanced materials you were talking about?
Yeah, researchers are developing new materials for lithium-ion batteries that are less flammable and less prone to thermal runaway. For example, some researchers are exploring the use of ceramic electrolytes instead of liquid electrolytes. Other researchers are exploring the use of silicone or other high-capacity anodes that are increasing energy density while reducing the risk of thermal runaway.
And you mentioned the standards and regulation changes. What can you tell us about those?
Safety standards and regulations are critical for ensuring the safe design, testing, and operation of lithium-ion batteries. Government and regulatory agencies are actively working on developing and implementing new safety standards and regulations for lithium-ion batteries. These standards will help ensure that lithium-ion batteries are safe for use in a wide range of applications.
So overall, I would say the future developments in lithium-ion battery technology are focused on safety and improving lithium-ion batteries and reducing risks of thermal runaways, battery fires, and explosions. These developments should ensure that lithium-ion batteries are safe to use in consumer electronics, electric vehicles, and even renewable energy storage systems. So just to recap this episode, we've covered lithium-ion technology and how it functions. We talked about some of the risks and best practices associated with lithium-ion technology. We talked about some of the causes of lithium-ion battery fires, some safety standards that are applicable. We also covered some of the issues that the fire service is facing, went over some case studies, and then talked about how some of the future technology based around lithium-ion batteries could impact the fire service and impact your safety at home. And if you live in the Boiling Springs Fire District jurisdiction, look at the description of this video. I'm going to put a link to the Greenville County recycling programs. I want to take this moment to really just give a special thank you to my guest, Engineer Hayden Knapp, for taking the time to sit in with me today and to help you guys understand what we're facing in the fire service with lithium-ion technology. So thank you, Hayden.
Yeah, absolutely. I had a lot of fun.
If I can ask our listeners to do two things for me. The first is go home and take an inventory of all the lithium-ion devices or batteries that you use in your home. And then the second is just to exercise as much caution as you can when using, charging, or disposing of those devices. This podcast was made possible by the Boiling Springs Fire District in Greenville, South Carolina. Thank you very much for being with me today. I'm Captain Chris Kamesho. Stay safe out there.
#HaveAFireSafeDay.